Okay, we're going to work on 1.7. So grab those notes, and it's just a couple of word problems. In particular, I want to focus on this box problem. So what you have is you start with this 8-inch piece of paper, which you can see at the 8 by 15, excuse me, which you can see at the bottom of the paper. So this is, I'm going to put it up here. This whole distance is 8. This whole distance is 15. That's what your 8 by 15 gets you. Okay? So what happens then is you cut out squares from each corner that are x inches long. So if you wanted to label that, that's an x, 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 that's an x. Okay, this is getting a bit long. So you cut those off. So those are gone. So picture these then going, this square has been removed. And this square has been removed. Okay, so now you remove those 4 squares, and then what you do is you fold up the sides. So when we fold up the sides, we now have this. This is the base now from here to here. This is the front from here to here, and so on and so forth, all the way around. So if you look at this long side right here, this is going to be 15 inches, but we removed 2 x's, yeah? Front, that's this distance right here. It's going to be 8 inches, but we remove 2 x's. And then how high is the water, mama? X units high, yeah? Because we fold this up. So here's my bottom, 15 minus the 2x, front 8 minus 2x, side 15 minus 2x, back 8 minus the 2x's, and then these sides are now x units high. So it's talking about the volume, right? The volume is a function of x. Okay, that's pretty easy. We know that volume is equal to length times width times height. Got it. Find the domain. The domain is what can x be? Before you start saying it can be anything. Well, it's got to be greater than 0. If I don't cut in at all, I know that I am going to just have a flat surface, and we are attempting to make a box, an open top box. So I know my domain is going to start at 0, got to be bigger than 0, and we're going to go up to how high can we go? I could be 0, I could be 1, I could be 2, I could be 3, I could be 4, I could be 5. Wait a second here. Wait a second. If I'm cutting in from here and in from here, eventually you're going to be cutting the paper in half, which we don't really want to do. So I'm going to have to say, well, how far could I go? Well, if x is 4, 8 minus 8, that would be 0. I wouldn't have a box, I would have 2 halves of a piece of paper. So we could go up to 4, but not be 4. I could be just before 4, and we can now we can calculate our volume, or we can graph this thing. So it says graph v as a function of x over the domain found in part A. So this is going to have to be for our window, for our domain. Use the maximum finder on your grapher. A grapher is also known as a calculator to determine the maximum volume such a box can hold. How big should the squares be cut out? Okay, so let's grab your calculator. We're going to type we don't have to multiply this out right now. We can type that into our calculator. So I gotta go call up the old calculator here, and we should probably clear that. And you wrote that sucker down, so let's do this. Here we go. I'm gonna go on my calculator. I'm gonna go to y equals. If you've got something in there, clear it out. I'm gonna go 15 minus 2x times 8 minus 2x times x. There's my equation that I want to find the maximum of to maximize the volume. Well, that's just going to be something that I can graph. And first we can find the, we can go to the window, and I want to think about my domain. I said 0 to 4 makes the most sense. So this is x minimum is 0, x maximum is 4. I'm going to count by ones. And then my y's. This y's are going to be the volume that we get. 0 to, I don't know. What's a volume of a box that makes sense? I'm going to go to 200. I have no idea. And I'm going to count by 20s. Okay? The rest of it is just whatever. So I'm guesstimating on that, the y. So let's take a look at the graph. Here comes my graph. The x's upon the bottoms are, okay, so my 200 was a little bit high. I could go back and change it, but I don't have to because I can clearly see where is a maximum going to occur. The maximum value is going to occur right in here. Yeah. So it looks to me like this is x is 1, x is 2, x is 3, x is 4. Remember, we can't have an x is 4, so this is the only domain that makes sense. So it's going to be somewhere in here, and if only my calculator could tell me that value, and in fact it will. And then this will be my maximum value. I'll get an ordered pair that is going to give me the square to cut out that gives me the maximum value. So I can go to, remember, second trace. That's calculate, second trace. And I can calculate, and I want to calculate a maximum. Yeah, I could hit number 4, or I can scroll down to the 4 and hit enter. So that's second and trace. And now I want to go left bound. I'm going to surround my maximum value. So click over to the left, everything in the box to the left, and we're doing a box. Oh, enter. And then I can click to the right bound. So I'm surrounding my maximum value, and I'm asking my calculator, find me the maximum that is in between this interval that I have set up. I know my high point is in there, and it's asking me if I want to guess. So you got to hit enter another time. Some people don't do that. So my answer is going to be, here's my, it's the max is at x equals 1.6 repeating, or 1 2/3 of an inch. And then the maximum itself is going to be the maximum of the volume is going to be at the y, which is 90.7 would be inches cubed. Okay, so in order to maximize our volume of a box, I need to cut in 1 2/3 of an inch. That's what we're looking for here. So you're going to need to write an equation, graph it, calculate the maximum for a problem like that. The calculator does a lot of the heavy lifting here. We didn't even have to FOIL this out. Some people want to multiply this all together. We didn't have to do that because it handles it. Isn't that great? Isn't that great? Okay. Let's head back to See if there's other problems that we want to take a look at here. Here's this one. Oh, I got all the answers. Yep, I did great. I don't understand why they tell me the domain. This always bothers me. I think this is an error. Because if you had 0, you don't have a box. If you have 4, you don't have a box. The endpoints give no volume. Well, you're looking for a box. What's the definition of a box? It's got to have sides. So I don't like that. But hey, that looks like ours. But we had a different looking graph because we just did a different window. Solution problems. How much 15% solution and how much 60% solution can be mixed together to get 90 gallons. This one you can actually kind of figure out on your own, but here's the equations for it. X is the gallons of 15%, 90 minus X is the gallons of 60%. So what you're doing here is you're taking, this is the percent, and this is how much, X gallons. If I use X gallons here, and I want 90 total, then if this is X, this is 90 minus X. There's a bunch of these problems in your homework. They have them set up for you there as well. So ready to go. So percent plus percent equals percent, and we want 30% at 90 gallons. And then that can be solved, and you get 60 and 60. You can solve the equation. Work rate problems is a little bit more, and it takes 3 hours to complete a room. 3 hours per room. Dan takes 5 hours per room, and Fran takes 2 hours per room. So you want to think about it as in terms of a rate. So you want a rate per room because we're going to do one room. So you want to think about Anne. Anne can do a third of a room per hour, right? And then Dan is a slug. He doesn't paint very well. A fifth of a room per hour. And Fran is the pro. A half a room per hour. So you gotta kind of these work problems because we're trying to complete one room. So it's like if I've got Anne's rate at a third of a room per hour times how long, because they're all going to work the same amount of time, plus Dan is a fifth of a room per hour times how long, plus Fran the pro doing most of the work, half a room per hour times how long to do one room. So it's a third of a room per hour times this many hours. That gives you how much of the room that Anne will do, and then how much will Dan do, and how much will Fran do. A little adding fractions here. I think is 30 the common denominator? 10 thirtieths plus 6 thirtieths plus 15 thirtieths. Well, this pen isn't working. X equals 1. You add those together, 25, 31 thirtieths X equals 1. Multiply by the reciprocal. X is 1 times 30 over 31. You could figure out what that is of an hour. It's like 58 minutes. And it should make sense that Fran takes 2 hours to do one room, Dan 5. If they're working together, it's going to take them less than an hour, just shy of an hour. But this is kind of a rate problem, so you have to think of it a little bit differently. A third of an hour, because 3 hours to do one room, so a third of a room per hour, and so on and so forth. It's a little work problem there. These are on here because you need. Whoa, what's going on? These are on here because you need to remember 30, 60, 90s, and 45, 45, 90s. Please, you're going to need these all year long. 1, 2, square root 3, 45, 45, 90s, isosceles right triangles. 1, 1, square root 2. So please remember special right triangles. They will come up again in this class for a while. Okay, that's all for today. You can get going, finish your 1-7 if you haven't already done so.